Let's go ahead and code binary search algorithm. First thing I'm going to do is I'm going to create a new package. I'm going to call it binary search, similar to our previous example of linear search. I'm going to create two classes. The first is going to be the main class. This is where our function is going to be called for binary search. And then I'm going to create our binary search class. Binary search class. Similar to our linear search example, my binary search class is going to have a function called search. It's going to be public int. It's going to return the index, so that's going to be a number. Search we're going to have the same number of inputs like we had for linear search, and we're going to get an array of numbers. We'll call it input array. And then the second parameter is going to be the number we are trying to find. So number to find. I'm going to get an error, so just fix it, and I'll also return -1, and this will fix this one. Remember from our steps, the first step in binary search, we are going to identify the start and the end index. Our start index is going to be the first position in the array. So this is going to be index number 0. So I'm going to say declare two variables, start index. I'm going to assign 0. The second one is going to be end index, and I'm going to assign the last index in the array. And the last index can be calculated by getting the length of the array minus 1. So now I have my starting index and ending index. The third step is to loop through the array. And in this case, remember, we need a condition, so we are going to use a while loop. So I'm going to have my while, and then comes the condition. Remember, the condition is unless the start and start index doesn't cross into end index, or basically start and end index don't cross each other, we will keep looping through. So this translates to code. We'll say start index is less than or equal to end index. So we're going to keep continuing looping. This while loop is going to keep running as long as the start index is less than equal to end index. Inside the loop, the first step is going to be to calculate the midpoint. So I'm going to declare a variable midpoint index. We're going to calculate the index, the midpoint index, by adding the start and the end index, and then dividing it by 2. This is going to return the quotient, and that would be the midpoint. The next step is to check the conditions. Remember, we have 3 conditions. If the number we are trying to find is equal to the number that is at the midpoint, or greater than or less than. So let's go ahead and check our first condition. So if input array midpoint index, if the number at the midpoint index is equal to the number that we are trying to find, which is number to find, this means our processing is done. We have found the number. So we're going to return the index. Okay. Else, if we're going to check if the number at the midpoint is greater. So we'll say, let's go ahead and get the midpoint, the number at the midpoint index. We'll say is greater than the number that you are trying to find. In this case, what is going to happen? We are going to discard our right side of the array. This means if the number at the midpoint index is greater than the number we are trying to find, this means the number exists on the left side of the array. So we need to discard the right side. How do we discard? Discard means moving the ending index. So we're going to move the end index. Our starting index will remain at the same position. And how does the end index move? Or what position does the end index move to? It moves to midpoint minus 1 position. Okay. Our last condition, if the input array at that midpoint index, the element at the midpoint index is less than the number to find, we don't need to put in else if, because that's the last condition anyway. In that case, what we are going to do, we are going to move the starting index, because this means that the left side of the array, there's no possibility that the number exists in the left side of the array. So we're going to move our starting index. And remember, when we move our start index, we are adding it to the midpoint index. So we're going to say it's going to be +1. Okay, and that should be it. This is our binary search algorithm. 3 conditions, our while loop. I'm going to save this, format it, save this, and then we'll go ahead and try, see if we are able to run this algorithm. So I'll go back to my main class, and I'm going to initialize the input array. So I'm going to say array input array. Okay, now I'll say int, and I'll just initialize it over here. Okay, I'm going to copy the numbers over from our previous example. Remember, if you're using binary search algorithm, you need to ensure that the array that we are passing is sorted. So in this case, this is a sorted array, and int number to find, let's go ahead and find the number 6. If our search algorithm is working, then we should get the position 0, 1, 2, 3, 4, 5. At index number 5, that's where my number 6 exists. So I'm going to go ahead and instantiate an object for my binary search class, new binary search, and then I'm going to call the function search, and it is going to return me a integer which is going to be the index number. So I'm going to, similar to our linear search, I'm going to save it to a variable index found. I'm going to say binary search dot search, pass in the input array that is on line number 6, then pass the number to find, which is 6 on line number 7, and that should be it. Let's go ahead and print the index found so we can test this function and see if it is working. So I'm going to go ahead and run this function. Okay, in this case, as you see on the console, we're getting 5. So this means the number 6 that we were trying to find exists on position number 5 or index number 5, which is correct. Let's go ahead and try to find number 19. That's at the last index. Okay, so we get the index number 10. Let's go ahead and, so we are getting the index number 10. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, because we have 11 elements in the array. Let's go ahead and test it for a number that does not exist in the array. For example, number 18, we should get -1 back. So that's looks like our binary search algorithm is working. Let's go back over here. Similar to our linear search, a couple of modifications, just the refactoring. Remember, I talked about the return statement in linear search. We have 2 return statements, not a big deal, but I prefer that we only have a single return statement, single exit point from our code. Not a whole lot of change. What we can do is we can introduce a new variable. I will say return index, and I'm going to assign -1 to it. Okay, now instead of doing a return over here, I'm going to simply say that the variable that I just created, actually I'll come back to this, in my return statement at the bottom, I'm going to return the variable that I created on the top always. Okay. Now in this case, I need only a single return statement, so we won't be needing this. Instead, what I'm going to do is I'm going to say the variable that I just created on the top, return index, I'm going to assign the midpoint index to it. Okay. Now, since there is no return over here, if we find the number, this is going to keep looping through until the loop ends. But we don't want that. If this condition becomes true, remember we have found what we're looking for. We need to stop the processing. Currently, it won't stop processing because we don't have a return statement over here. It will keep looping through. So for that, what we just need to do is add a break statement. What this is going to happen is as soon as I find the number I'm looking for, it is going to stop the processing by this break statement. This break is going to exit the loop, the while loop over here, and then come to line number 23. Now, this shouldn't change any functionality. So the same test that we performed, we'll go ahead and do that. So in this case, the first thing we did was number 6. We should still get back 5. And then we tested with number 19. Oops, number 19, and we should get back 10. That's still working. And if you pass a number that does not exist in the array, it should return -1. And there it is. So we have completed all the tests. A little bit modification, just refactoring some of the code, but this is how binary search code looks like.